Hello everybody, thank you for joining us today. I am your host Philip, and today I am joined by our friends from StatiCa, Uri and Vit, who will be pretty much doing all the hard work and delivering today's presentation content. Some housekeeping items from me before we begin properly. Please note that we will be offering question and answer today following the presentation. As indicated on the screen earlier, questions can be submitted at any time using the GoToWebinar application. Some of you may get answers in the chat window as we proceed, but we will address others at the close, particularly those that we believe will interest the total group. So do please submit questions as we go along, and we can prioritize and answer as we go. I do urge you to now close all other applications other than GoToWebinar, and there's some very good presentations as part of this content, so do view in full screen mode so that you can appreciate the demos and make sure you really understand what we're showing you today. The webinar is being recorded. This is usual, so you will have the opportunity to go back and revisit what you see live or recommend to colleagues. Our aim is to post the recording as soon as possible, and it may well be in place today. That will be accessed by our Wednesday webinar page at tekla.com, and you as registers for the webinar will get a notification. So just a brief introduction. As you know, today's content focuses on the Trimble IDEA partnership and the strong synergy between the advanced structural engineering products that we bring to market. The goal in the next 40 or so minutes is to look at this latest Tekla Structures interoperability link that supports our commitment to Open BIM. We intend to show how Tekla Structures and StatiCa's finite element modeling can combine to deliver construction-ready complex connection design. And what will be demonstrated today does result from close cooperation to create a plugin using the Tekla Structures Open API. That plugin will allow even the most complicated nodes formed from a number of standard connections and manually modeled steel objects, bolts and welds to transfer easily into IDEA StatiCa application. Here's our agenda, not necessarily in this order, but it's our intention to give you an overview of the IDEA StatiCa solution and code base. We have testimonials from existing customers, and we will be giving you an overview of the Tekla Structures plugin. Most importantly, there is a live demonstration to show you how it works, and then we will touch on the customer benefits of the pairing of Tekla Structures with IDEA StatiCa software. We will finish with, as already said, the Q&A. So without further delay, I would now like to hand over to Uri, who will start the presentation with an overview of IDEA StatiCa. Over to you, Uri.
Thanks a lot, Philip. Hello to everybody. It's been a couple of years since we've been working together, IDEA StatiCa and Trimble. We are a proud partner in A&D segment. In our team, we have a group of experienced people, former structural engineers, software engineers working on tools that we link to key products Tekla has and offers to the engineering audience. IDEA StatiCa is focused on the details. It is a software for code checking, structural design of joints, cross-sections and other details. If you are aware of Tekla Structural Designer, that is an actual finite element analysis tool to analyze and do the structural design of the whole model. IDEA StatiCa is focused on the details. Today is about steel connections, steel joints, and how it works with Tekla Structures. We cooperate a lot with the universities to validate the results we use and the methods that are embedded in the software, and behind this more than 35 people working on it to get it in a shape that it's usable by any structural engineer fabricator worldwide. In our steel projects, we have two types of joints we encounter. We have the standards, the easy joints, and then we have the non-standards, the difficult ones. For the standard, we know very well how to deal with them. We have design guides, we have predefined examples, we have our past experience. And as long as we stay in these predefined templates, we are very good to go. And the design is rather easy. When we have to step out of these standard topologies, there is a way. Especially experienced engineers, they're able to build a model of the joint in an advanced finite element tool, do the code check-in in Excel spreadsheets to actually take into account all the local specifics. It requires a little bit of estimation and experience. The more skilled engineers do that, sometimes honestly, it's just better to avoid using the non-standard joint and adjust the project or spend more time on it. This leads to a little bit of paradox that even though 70% of joints in steel structures are the easy ones, the standard, we spend most of the time, spend 70% of the time on the difficult ones, on the 30% of difficult joints. To illustrate this is one of our biggest Tekla idea customers, Arup, using this workflow in their offices in UK, US, Australia, and they had the direct comparison because they have been in the industry for quite some time. 10 years ago, they were designing a Leadenhall Tower in London with a joint like this. So retrospectively, they tried to do this in Idea StatiCa, and they know 10 years ago it was a laborious process, couple of weeks of iterations using multiple tools. Today, much quicker, much simpler way with Tekla structures and Idea StatiCa. This workflow delivers structural design and code check of all steel joints, not just the standard, not just the non-standard. Do them all and do them in minutes. We can design and check 2D frames, trusses, 3D frames, trusses, footing, anchoring, everything that is possible in a steel project, no matter the complexity. The analysis usually starts to with the get the stress strain diagram of the joint. Usually buckling stiffness is required as well. Pretty much everything that is needed for an overall check. Let's look at examples. This is a complex joint in an electricity tower mast with seemingly suspicious topology of bolts, and it's correct. If we do not understand the joint, we can get wrong topology like this. That's displayed by the red indications, the bolts, that they are overpressurized and the design is not safe. It would collapse. If we understand this, have a tool, can rearrange the bolts, check it again, come up with a safe design. Sometimes the joint is okay from the point of stress and strain, but there might be buckling, like in this example, steel warehouse joint. We're going to simply add a stiffener, either in Tekla or in Idea StatiCa, run the check again and see that we fixed the problem. Sometimes we can optimize. If you understand the joint, like this one, we can cut the second tube as well, get stiffness 10 times higher for the same money. 3 years ago, there was this steel service bridge being designed in Heathrow Airport, UK. And this particular joint was a non-standard, couldn't be checked by any other tool with IDEA StatiCa. A proper design, a safe design was achieved and presented to the authorities who accepted it. A big customer of Tekla structures and IDEA StatiCa, content engineering, is using this workflow to speed up their processes every day. We've developed an interface which is automatically embedded between IDEA and Tekla. That's a joint effort of our development team and the team of Tekla. We are actually working with the API. We've created a one-way link we will show, and we have more plans for the future. We can discuss that as well. Inside the software, there's a new method which needs to be tested. So for quite some time, we've been working on the comparison, on the verification work. So we took all the standard joints and connections from design guides, either Eurocode or US, and recalculate in IDEA StatiCa. And we got the same results. Not identical, as we are working with final elements, but always within the safety factor of the code. The complex joints are not so easy to check as there are no predefined examples. So the university is working with us. They spend a lot of time modeling complex joints in very scientific final element programs and comparing the results with IDEA StatiCa. Again, very, very similar results. Third level was to do live tests and then publish everything, make it available, make everybody able to challenge this approach. So we publish it online on conferences at our website, and the universities also published a summary of it, a book, benchmark cases for advanced design of structural steel connections, selected set of benchmark cases which show the comparison between IDEA StatiCa and the conventional component method, and it's a look inside how it works, how it can be checked. And this sophisticated method, it took us quite some time to develop it. It is in the software, but it's hidden. It was transformed into a fun tool to model joints. We implemented the modeling principles very similar to Tekla structures. That means you are constructing the joint with parts you know, adding plates, welds, bolts to build any shape. And the same principle allowed us to link those two solutions, so we can recognize the objects in Tekla and send them to IDEA one-to-one, and basically skip this process, save a lot of time we already spent modeling in Tekla structures. We support Eurocode and the US code. More codes will be added. We gradually improve and add various material types, cross-sections, bolts. We have different types of reports and also produce schemes and drawings. It is important to show all the references to the code. This is a code checking software, so it all goes down to answering a question. Is it safe? Is it buildable? Is it okay by the code? So we display all the checks defined by Eurocode or the US code with a clear pass answer. Not just the answer, you can look into the actual calculations, display the formulas, check it for yourself if you want to. 3 levels of report we will show live. This is a very enthusiastic Tekla structures user from Spain. In Ingenieria outlet engineering that's doing projects in Spain, North Africa, Latin America a lot, and they are always looking for ways how to shorten the design process. With Tekla structures and IDEA StatiCa, they can do that. We have prepared two examples to show this live. These two joints, we will open them in Tekla Structures 2016 and send them to IDEA to do a proper design and code check. I will hand it over to my colleague Viet, who will guide us through both the examples.
Hello. Let's open the project file in Tekla Structures and check this frame joint in IDEA StatiCa. To export it from Tekla, we choose the appropriate button in the top ribbon according to the code which we need, Eurocode or US code. Next step is that we select the point which will be representing the node. Next step is to choose all structural members of the joint. First chosen member will be the bearing one. Last step is to choose all remaining parts like plates, welds and bolts. IDEA StatiCa connection window will automatically appear after saving the project file. We imported the geometry, the cross-sections, and all needed data from the Tekla structures. When we import the model from CAD program like Tekla Structures, we need to import or input the load cases, load effects, to load the members. In this example, we have many members. We can easily input the internal forces from the Excel spreadsheet. Let's check this joint by stress and strain analysis. Now the nonlinear calculation is being processed. The load is applied in steps and the software finds the equilibrium in an iterative way. We will explore the results now. Utilization of all parts of the joint is displayed. In the main window, we can see the colored 3D model. The gray parts are utilized less than 60% of the limit. The green ones less than 95% of the limit. The orange ones less than 100% of the limit. The red parts of the connection did not pass the code check. This traffic light function helps to identify the overloaded parts in seconds. Let's see the equivalent stress, mesh and deformed view of the model. The results are also presented for each of the finite elements of the weld. We can see right away how the welds are utilized. If we select a component in 3D view, for example, this weld, IDEA StatiCa will show the results for this component in result tables. The formulas and the values which are used for the code check are presented too. We provide this information for welds, bolts and anchors. IDEA StatiCa connection offers 3 options of reporting. Summary, one page and detailed. It can be modified. For example, we will turn on the views in geometry, add a bill of material with drawings. We refresh and the report is completed. The report can be exported and opened as an editable document. The tables and the figures can be further used. We have designed and checked the frame joint using Tekla structures and idea StatiCa. Now we will proceed to the next example. Let's open the project. To export it from Tekla, we choose the appropriate button in the top ribbon. And again, the first step is to choose the point which will be representing the node. After that, we will choose all structural members of the joint. First chosen member will be the bearing one. Last step is to choose all other entities like plates, bolts and welds. Idea StatiCa connection window will automatically appear after saving the project file. We imported geometry, cross-sections and all needed data from the Tekla structures. When we import model from CAD program like Tekla, we have to input internal forces to load the members. This time we will input the internal forces manually. Now we loaded the model. We can choose the type of shear force transfer for the bolts. We can choose between the bearing, tension shear interaction and friction. Friction is option for preloaded bolts. Let's check this joint by a stress-strain analysis. We will explore the results now. Utilization of all parts of the joint is displayed. Let's select the most utilized bolt, the orange one. Idea StatiCa will guide us through the results for this bolt. We can see the values for code check. Let's see the equivalent stress, mesh and bolt forces. If we select the green arrow in 3D view, which represent the tension force in a bolt, Idea StatiCa will show the results for this component in the result tables. Again, all values and formulas are presented. We provide this information for bolts, welds and anchors. We can do buckling analysis too. The factors of critical loads are presented, and we can see buckling shapes for each factor. Idea StatiCa offers a bill of material, and we can add drawings with dimensions of all entities, holes, edges, etc. We can export this draft to DXF file and for further use. Let's prepare a report. with buckling results and drawings. We refresh and the document will be completed. We have designed and checked the frame joint using Tekla structures and Idea StatiCa. Now I will hand it over to Philip to wrap up the benefits of using Tekla structures and Idea StatiCa.
Thank you very much. That was a great demo. So we are on our way to Q&A now. We'll just let Vit review the questions we've had in. Do please submit your questions based on the presentation, and as you were told, let's have a quick look at the benefits of pairing Tekla structures and Idea StatiCa. It is really all down to the ability to produce the construction ready model with Tekla structures regardless of project size. Level of development 400 is easily within our capabilities, giving you the opportunity to save time and reduce potential errors by not having to recreate the node in separate or different applications. There is clearly no software limitation, so no need to subdivide a large project or simplify the connection node into smaller components. Obviously, as already mentioned, the fabrication model can be used, including all material bolts and welds information for efficiency. Combined connections and manually added stiffeners can be adopted rather than just standard joints. That fabrication model, complete with all machine preparations needed for manufacture, can be used to minimize the risk of structural defects regardless of the complexity of the node and connection. Clearly there is the opportunity to do some material savings and a lot of opportunity to reduce the preparation time for the connected calculations. And as was pointed out in the presentation, using Idea StatiCa provides clear results for verification by other external engineers, contractors, or local authorities. So I think the synergies with the software are quite clear. So how do you get your hands on it? The plugin is available from Tekla Warehouse as a download. And for those of you who have yet to experience Idea StatiCa software, you have the opportunity to enjoy a 14-day free trial to experience its power. Just a quick poll for you to see who's interested in actually taking on the 14-day trial. You should have the opportunity to register your interest on screen now. A simple yes, no, but we would be interested for those who have already tested, and an idea of how many of you out there are already customers of Idea StatiCa. So a few moments to complete that, and then I will be inviting Juraj to rejoin us and have a look at some of the many questions that you have submitted on today's topic. So looks like we've got a good response. A very high percentage of you are interested in having a look at the software, which is great. Obviously a lot of Idea StatiCa customers out there already. If those of you are not Tekla users, perhaps you want to contact us to look at that as well. So without further delay, Juraj, are you ready and able to join us to have a look at some of the questions?
Sure. Thank you, Philip. First question is, if the meshing is done automatically, and if we can adjust it, for example, the mesh size?
Well, this is a good question. As you see from the pictures, we had a group of scientists to fine-tune our method, and we have default values for mesh size. With these default values, the model is going well. It creates and gives results very well. But if you want, user or you can change the values of mesh. It's a little bit hide from the user, but it can be changed in the code setup. And for example, you can change number of finite elements on the edge, or minimal size of the element, or the maximal size. So it can be tuned, but it's not necessary.
Okay, everything running automatically. Thank you. Another question is, what are other options to get the load effects to IDEA StatiCa? We've seen actually copy-pasting it from Excel spreadsheet and input it manually. There's a question if it is possible from StatPro or a program like that.
Yes, of course, we have another option. We showed here a BIM link between CAD program, and we can, or we have a link between FEM program, for example, StatPro, Robot, SCI Engineer, and others. You can create your FEM finite element construction model, the global model, and then export only the joint and the internal forces only in the joint. But then you have to create your joint in way of plates, welds, and everything in the IDEA StatiCa connection.
Very well. Next question. Does the finite element analysis respect ductility of the welds?
Yes, of course. Our finite elements for the welds respect the geometry of the weld. Actually, the finite elements has the own working diagram, bilinear working diagram, and it helps us to correspond with the reality. We can easily design the welds. We can cover the correct length of the weld in the connections.
Very well. The next question is about, actually there's some more questions about other codes like Australian, Russian. We have a question about Canadian as well. So I will update that. As of today, it's Eurocode and US. In June, that's in 30 days, Canadian code will be implemented, Australian code end of this year, and more will come in the next period that will be defined. There's a group of questions about actually expanding the interoperability of the Tekla link, which is great to see. There seems to be a lot of advanced users. It all goes around selecting more joins in Tekla. That's one question. If it is possible to select more joins in Tekla structures and send it to IDEA. As of today, no. But that's exactly the way we are pushing this forward, to be able to work with groups of joins, identify them, keep them in groups, design similar joins or identical joins at one go. Next couple of questions is about how to send the information back. That means from IDEA StatiCa to somehow update the model in Tekla structures. This is also a good topic, and we will have the first version of this in October. How we can make the iterative process of Tekla IDEA more easy, so it remembers the changes and make it much more easier to update the information in Tekla structures as the key model to use. Right. Then we had a question about rivets. When we can design rivets. Yes, we can, and we are improving this for the next release as well. It's a little bit specific topic. Okay. Another question is if for some reason if we can design a joint without Tekla. Yes, Idea StatiCa works as well as a standalone application. That means that we can design the joint from scratch in Idea StatiCa. Yeah. All right. All right. Another question about CI Engineer, if we can create a joint there and send it to Idea StatiCa. Yes, there's a direct link that enables that with a different set of information as we've described. Yep. We have questions about the new joint resistance functionality, which was implemented in the last release. Maybe we can get in touch after the webinar to show that. Yep. All right, let me check. Let me check if we have there's quite a few questions. I'm trying to group them. Philip, maybe you can do the wrap-up and we'll look into more questions we can discuss together.
That would be absolutely fine, yes. Just to share with you, there's obviously a very high level of interest, which is great. We've got lots of questions from you. So whilst Juraj looks at the next one to address, let me just remind you that if you do have any other questions that occur to you after the webinar, you can submit them to us by email, tekla.webinar@trimble.com. And I can say some people are using that at the same time as the GoToWebinar at the moment, so a lot of interest. We will be having another Wednesday webinar, 5th of July, again looking at a partnership with between Tekla Structures and, in this case, Rhino Grasshopper. So it's an open invitation to join us to learn more about algorithmic modeling and parametric design in Tekla Structures using a Rhino Grasshopper plugin. So do please remember that that's happening. The registration page will be, but is not yet on the Tekla webinar page. That should be there in the next day or two, and there will be a poll. Do please stay online afterwards, and you'll receive a feedback poll to tell us how you found the webinar. It's always useful to get your feedback, particularly on this topic with regard to featuring partner products. So perhaps you could take the time to complete that and let us have it back. We do have time for some more questions, so if you want to come back to us, we can work through a few more questions, Juraj.
All right. A question is there a library available for historic sections if we can, if the user can define their own? Yes, we've implemented a wide range of libraries of cross sections. And directly in Idea StatiCa we can create a general one and it can be used subsequently in other projects. We have one more question about the stresses. Is it possible to view results for stresses other than von Mises stresses in Idea StatiCa to, for example, separate shear stresses from normal stresses?
That will be a question for me, I suppose. No, it's not. Now we can see only the equivalent stress, the von Mises stress. And if you need or if you want to see the stresses only in one direction, for example for welds and bolts, these values are presented in the result tables. So you can see the values in the tables, not in the 3D scene.
All right. We have a question, how much is the program? All right. The full solution, including the interface to Tekla structures, costs 4,000 euros per license, and with discounts for more seats bought at the same time. We work with quite a few of Tekla partners, Tekla resellers, so they sell it together, Tekla structures and Idea StatiCa. You can check out our website, your closest partner, and you can get it at one stop. In other countries, we have other partners, or you can contact us directly. Questions about the Egyptian and Russian standards? This is not yet in the plan. We will be happy if we get more attention and interesting projects there, so we can make it a priority. All right.
I was just going to prompt you. You've had a question on price. Would you like to tell our audience with regard to further information where they can go to buy?
Yes, sure. We'll be sending a follow-up after this webinar, and we have a list of all our resellers at our website with responsible person and contact information for that particular territory, and sometimes it might be the same person you purchase Tekla structures from, which makes it a lot more easier.
Thank you.
One last question. If we are doing internal nodes of the joints, is there some insurance that this software will give us 100% right results if we provide right forces? That's a very good question. Structural engineer, he always works with the whole model first. That means if you're a Tekla structural designer, you get all the load combinations for the frames, for the whole structure, and then you take the result, take all these forces and apply them on the joint. So if we have this information, Idea StatiCa calculates everything right, correct, guaranteed, but it's responsibility of the engineer to get the proper loading in the global analysis. We also, I think let's make it the last question, how does the cloud version work? We have created 3 months ago a simplified version of this application and put it online. We took a different approach. We created hundreds of predefined templates of steel connections, steel joints that can be in a few clicks designed and checked online, only using your web browser. You can also check it out. It's a new thing, a different approach, where we have hundreds of predefined examples to choose from, and in the future we will be looking at how to integrate it more in the whole design process.
So thank you, Juraj. Thank you to Vid for the demonstration. Thank you to everyone that submitted questions, and obviously we will get answers to those that we were not able to address live today. We do appreciate you attending, so thank you for being with us. This seems to have been a very interesting topic, so do please fill in our poll after the webinar and let us know how you found the webinar. We look forward to speaking with you again, and I'm sure you'll be hearing from our friends at Idea StatiCa, particularly those of you who registered interest in the 14-day trial. So thanks for all of us. Hopefully speak to you again in a month's time with regard to Tekla structures and Rhino Grasshopper. Thank you and goodbye.